The deep ocean is not just unexplored. It actively resists exploration. Light disappears. Temperatures collapse. Pressure rises until steel itself begins to fail. And yet, beneath all of that, life still finds a way to exist. Across the deep ocean, animals have evolved to survive in the cold, the dark, and the crushing pressure. Entire ecosystems exist without sunlight, relying instead on chemical vents, drifting carcasses, and whatever energy happens to fall from above. But now, we're going further than almost anyone ever has. Because at the very bottom of the Pacific Ocean, the sea floor opens into a place once believed to be completely lifeless. A place so hostile that for most of human history, it was considered an impossible frontier. This is the Mariana Trench, and this is our descent into the abyss. The Mariana Trench lies like a massive scar in the Earth's crust, a crescent-shaped fracture stretching roughly 2,550 kilometers long and plunging nearly 11 kilometers downward into total darkness. At its deepest point lies the Challenger Deep, the lowest known place on the planet, 11,033 meters beneath the surface. A depth so extreme that the pressure there is nearly 1,000 times greater than what you feel at sea level. To put that into perspective, every square inch of your body would be supporting the weight of a large car. The trench itself is part of a vast global network of deep ocean fractures formed by a process called subduction, where one tectonic plate is slowly forced beneath another. In the case of the Mariana Trench, the Pacific Plate is being pushed beneath the smaller Mariana Plate, creating a wound in the Earth that continues to deepen over time. Molten rock rising through this collision built the nearby Mariana Islands, but far below them lies something much more mysterious. A region of the ocean so extreme it was named after the underworld. This depth range is known as the Hadal Zone, named after Hades, the realm of the dead in Greek mythology, a fitting name for a place defined by eternal darkness, near freezing temperatures, acidic waters, scarce food, and pressure so immense it reshapes biology itself. For generations, scientists believed this zone was completely sterile, too deep, too cold, too crushed by pressure for anything to survive. An empty void. And for a long time, no one could prove otherwise. That changed in 1875. During a scientific expedition aboard the HMS Challenger, researchers lowered a weighted rope into the Pacific, expecting it to hit the seabed at a reasonable depth. It didn't. They kept feeding out rope, and then more rope. Eventually, they realized something unsettling. They had underestimated the depth of the ocean by a lot. The discovery of the Challenger Deep sent shockwaves through the scientific world. But knowing the abyss existed wasn't enough. The real question lingered for decades. What, if anything, could survive down there? 85 years later, in 1960, two men decided to find out. Jacques Piccard and U.S. Navy Lieutenant Don Walsh descended into the Mariana Trench aboard a small bathyscaphe called Trieste, a steel sphere barely large enough for two people, surrounded by total darkness. Their descent took nearly 5 hours. As they approached the bottom, the pressure outside the submersible became almost unimaginable. At one point, a loud crack echoed through the vessel. One of the viewing windows had partially failed. They only had minutes to observe the sea floor. But in those minutes, they saw something that changed everything. Life. Pale shrimp-like creatures, flat, flounder-shaped organisms, and a thick brown organic ooze coating the seabed. Against all expectations, the deepest place on Earth was not dead. Picard later described the moment as the answer to a question biologists had been asking for decades. Life could exist, even here. More than half a century later, in 2012, filmmaker and explorer James Cameron made a solo descent to the Challenger Deep aboard the Deep Sea Challenger. What he found confirmed and expanded upon Picard's discovery. The seafloor was covered in sprawling microbial mats, strange filament-like colonies of bacteria living without sunlight, feeding instead on chemicals released from altered rocks deep beneath the crust. This process, called chemosynthesis, is the deep sea's alternative to photosynthesis. It forms the foundation of an ecosystem that exists entirely independent of the sun. And these bacteria aren't just surviving, they're thriving. Some of the most revealing footage of this hidden world came not from human explorers, but from machines. In 1996, an unmanned Japanese submersible called Kaiko reached a depth of nearly 10,900 meters, setting a new record. Its mission was to collect samples of the microbial mats observed decades earlier. What scientists discovered was unsettling. Many of these microorganisms were obligately barophilic, meaning they require extreme pressure to survive. Remove them from the depths and they die. Life here wasn't merely enduring the pressure, it depended on it. Then, during a later dive in 1998, Kaiko encountered something even more unexpected. A massive amphipod species known as Hirondella gigas. This was a problem. At extreme depths, calcium carbonate, the material that forms shells and skeletons, dissolves more easily below about 5,000 meters. And yet here was an amphipod with a fully intact exoskeleton living at more than twice that depth. The secret turned out to be extraordinary. These creatures reinforce their shells with aluminum armor extracted from the surrounding seafloor mud through chemical processes in their gut, an adaptation unlike anything seen in shallow water life. In the Hadal Zone, evolution plays by different rules. More recent expeditions have revealed even stranger inhabitants. Sea cucumbers dominate much of the trench floor, including the bizarre sea pig, a soft balloon-like creature that walks along the mud using tube-shaped feet while sifting for food with ringed tentacles. Some scientists now believe that the fish observed by Picard in 1960 may have actually been a sea cucumber, as true fish are thought to be unable to survive pressures deep enough to dissolve vertebrate bone. The deepest confirmed fish species, the Mariana snailfish, lives at around 8,000 meters, still nearly 2 kilometers above the Challenger Deep. Discovered in 2014, it was named Pseudoliparis swire in honor of Herbert Swire, a member of the original HMS Challenger expedition. But fish and amphipods are only part of the story. Single-celled organisms called xenophyophores grow to sizes larger than a human hand. Predatory tunicates anchor themselves to canyon walls, waiting for drifting prey. And bioluminescent species manipulate light in total darkness to vanish from view. Life doesn't just exist here, it adapts in ways that challenge everything we think we know about biology. And yet, for all we've discovered, the Mariana Trench remains largely unexplored. We have mapped more of the surface of Mars than we have the depths of our own oceans. Entire ecosystems may exist below us, unseen, undocumented, and fragile. Studying these organisms could unlock breakthroughs in medicine, biotechnology, and our understanding of how life first emerged on Earth. But there's a problem. Even the deepest place on the planet is no longer beyond human reach. Plastic waste has already been found in the Challenger Deep, in a place humans have visited only a handful of times, which raises a troubling question. How many discoveries might vanish before we even realize they were there? The abyss is no longer unreachable, and what we choose to do next may decide whether its secrets are revealed or lost forever. If you have learned something today, please like, share, and subscribe to the channel for more videos like this.